we go over the understanding of coordination compounds and also the nomenclature or how to name them. A coordination compound consists of a complex ion and a counter ion, or, or just any other ion that is present together with a complex ion. So complex ion and also counter ion. An example we can give is, let's say we've been given silver plus. This is an ion. And so when this comes to react with, let's say, ammonia, okay, we know ammonia, the nitrogen has got two lone pairs. So this now forms this compound. Because the silver was positively charged, this carries a positive charge like that. So this thing we have here is a complex ion. Why are we calling it a complex ion? Because we have got, in it we have got a metal and also a ligand. Now when this complex ion is together with another, just another ion which can neutralize this charge, such we can call it as a coordination compound. Now we are saying ammonia here is a ligand. What then is a ligand? So a ligand is simply a compound that contains lone pairs which can be shared with other atoms. So we can see that this one contains lone pairs. Because of this, water also qualifies to be a ligand because oxygen has got lone pairs, chlorine, okay, just those, and just other more. Those can qualify to be ligands. Now, let's get to understand them better here. Of course, we are saying a combination of a complex ion and a counter ion is what we call a coordination compound. Now, we have got different kinds of ligands. There are some ligands which are neutral, others are not neutral, others are charged. So anything that contains a lone pair, that we can call it as a ligand. Some ligands which are neutral, we have got, we can talk of water. Water is a neutral molecule. Ammonia. We can talk of methylamine. This is methylamine. We can also talk of a carbonyl. We can talk of a nitrosyl. So all these here are ligands which are neutral. So we need to know their names when we are naming them as ligands in a complex or in a coordination compound. So for water we use aqua to name them. When we've got water is acting as a ligand in a compound, we use aqua. And this is ammonia. When it is acting as a ligand, we use amine. And we have got methylamine here. Well, an amine is simply a compound that contains this functional group. So we can see that even this one contains that functional group, just like ammonia. So because we have got a methyl at the beginning, this is going to be called methylamine. And this is a carbonyl group, a group which is also found in carbohydrates. And this is a nitrosyl. Okay, so these are the names which are going to appear when we are using these compounds as ligands. These are neutral ligands. Of course, they might not be the only ones. We can have even more others. Now, we also have those ligands which are not neutral, which are charged, like a fluorine ion, a chlorine ion. These all contain lone pairs. Iodine ions, we have got hydroxide, we have got also a cyanide, which is negative. So the names of these appear with the O, especially these which are group 7 elements or halogens. They appear with the O when you are using them as ligands. For example, this is going to be called, the fluorine will be called fluoro. This will be called chloro. And this is going to be called bromine, is called bromo. iodine is going to be called iodo. Now this is an hydroxide, so we call it hydroxo. And we have got a cyanide, which we call cyano. So these are some ligands which we have. Now we have got some ligands which have got more than one atom. So some ligands which have got more than one atom with a lone pair, those ligands have got a special name. So if we have got one with more than one pair, an example that we can give is ethylene diamine. So we just use En to represent that. The full name is ethylene diamine. So this ligand has got more than one atom which have got a lone pair, and so it is called a chelate or a chelating ligand. So that is the name. Now, how is this? So for ethylene diamine, we have got CH2, that's the structure, CH2, and there is a bond with an amine this side, also an amine this side, and hence called ethylene diamine. And we know that the nitrogen here has got lone pairs, so it is the presence of these lone pairs which make this to be a chelate. And we know for us to form a complex ion, a ligand is supposed to react or come together with a metal. So we can have a metal here such as copper, and this is going to form such bonds like that. So that is why we call this a bidentate ligand. That means it can form two bonds. Okay. Now, what else do we want to understand? So a ligand that can form only one bond is called monodentate or unidentate. And one which can form two, we call it a didentate. And something that can form more than two, we're going to call it a polydentate. Okay. Now, how do we get to name coordination compounds? Just what we have here, we need to understand it well. So for the ligands, I've already named them here. This is how we get to name them in a compound. Now, when we are naming coordination compounds, we don't only have a ligand. We have got a ligand together with some other ion. Now, how do we get to name them? So, at first, what we need to understand, just like when we are naming just ionic compounds, for example, sodium chloride, we have got a cation here, which is the sodium, and the anion, which is the chlorine. When you are naming this compound, you start first by naming the one which is positively charged, and then naming the one which is negatively charged. And so this is sodium chloride. With any other compound, you first name what is positive and negative. That is the same rule which applies when we are naming coordination compounds. So first, the first thing is name the cation first. That is the one which is positive, and then the anion. So that is the first thing. Now, since we know that in a coordination compound we have got a ligand together with some metal ion. So because of this, we first name the ligand. So the ligand name is named before the metal ion. So that is it. So when we have got, for example, we have got here we have got water. This is a ligand. Let's say it has reacted with some metal such as copper or something like that. So we're going to first name this. This is a ligand. So name this before you can name this. Okay. Okay, so in another thing, in naming ligands, an O is added to the most to the root name. As you get to name a ligand, you are going to add an O to the root name. Okay, so an example we can talk about is when you are naming, for example, bromide, you add an O, it becomes bromo, like that. And another thing, we have got also prefixes which get to follow when you have got more than one ligand. You can add prefixes such as di, tri, tetra, hexa, such. Now, we also have oxidation numbers of these compounds. So oxidation number of the central ion is designed by by a Roman numeral. Oxidation number of the central metal ion, we use a Roman numeral. Okay. Now, when we have got more than one ligand which are present in a coordination compound, you are going to name them alphabetically. You start with what you can name first according to the letters in the alphabetical order. Now, if the complex ion has a negative charge, then the naming will become a little bit different. So when it has a negative charge, in other words, it's acting as the anion. When the complex ion is the anion, then what you are going to do is to the suffix name, you are going to add ate. So these are the rules which we are going to be using when we get to name the compounds which we are going to look at. Now, we have got some Latin names of metals used in ionic form when they're acting as ion and anions in the coordination compound. That is, if they are the ones which are negatively charged. For example, if you have got an element, potassium, in a coordination compound, it is acting as a cation. It will be differently named when the same potassium is acting as an anion. So now how do we get to name them if they're acting as cations? So as anions, not cations. So we're going to talk of ion. Let me just give the name. Iron, copper, just some examples. We also have lead, also silver, also gold, also tin. So when these compounds are acting as anions, the naming becomes different. So for them, for example, iron, you use the Latin name ferret. For copper also, we use the Latin name that is cuprate. For lead, we also use plumbate. For silver, we use angetate. And for gold, we use orate. And then for tin, we use stenate. So whenever we see these compounds, they're acting as anions, they are negatively charged. Those are the names that we are going to give to them. Now let's get to understand how we get to name them. How do we get to name these complex ions or coordination compounds? The first one we have is this one here. How do we get to name it? CO, NH3, there is a 5, chlorine, and then another chlorine outside. Okay, there is our compound. Now, from here we can see that we have got first the compound, we have got this compound here, which is the ligand. So from the rules which you wrote, we said you get to first name the ligand. That is what we said. Now from here, we also have the metal which is attached to the ligand. We also have to name that. So in other words, this compound which is here is a complex ion. A complex ion is a substance which consists of a ligand and also the ion, the metal ion. Okay. Now, before we get to name this, we need to know the charge for the metal ion in this compound. And how do we get to know the charge? So all we are going to do is we are going to take we've got cobalt plus, how many ammonia molecules do we have? There are the 5 of them. But what is the charge of ammonia? This is one of the ligands we said is a neutral ligand, so it is 0 because it's neutral. And then plus, how many chlorines do we have here? We can see we have got 2 here and then 1, so we have got 3 of them. And each of them, they've got a negative charge because they are group 7 elements. And when you add all the oxidation numbers, it's supposed to add up to 0. So we're saying that CO 3 times negative 1, that will be negative 3, so it should be equal to 0. That means CO is equal to positive 3 if we take 3 the side. So this is the charge of the cobalt. And remember we said for the metal ion, each charge is going to be named in Roman numeral. So now we can name it, starting with first the ligand. Now as you name the ligand, you first look at how many are they. We have got 5 of them, so 5 we're going to put the prefix penta. Now this is ammonia. When you are naming ammonia a ligand, it's amine, so pentaamine. And then now we are going to name this one before we can name this one, because for this we need to put the Roman numeral there. So we are first naming this thing which is positively charged. The whole of this thing is positively charged and the chlorines are negatively charged. So we first name the anion. So that will be pentaamine chloro cobalt. The charge, that is a 3, so we put it in Roman numeral, and then we name the chloride. So this first part which appears is the name of the cation, and then the second part is the name of the anion. So that is how we get to name it. So that's pentaamine chlorocobalt 2, chlorocobalt 3 chloride. But this cobalt, if it was here, it wouldn't have been cobalt. That would have been cobaltate, because it would have been an ion. Now let's get to name the second one. In the same way we have done the first one, so we have got ion En2, that is ethylene diamine, and then we have got N2, we have got 2, there's a 2 there, and then we have got a sulfate. So which one is the ligand here? Or the ligand is this one, which is the ethylene diamine attached to the metal ion. And then we also have nitrogen dioxide there. Okay. Now, before we get to name this, we need to find the charge of the ion in this compound. The charge, we have got ion plus, how many ethylene diamines do we have? We have got 2 and we have got a 2 there, so that's a 4. So we have 4. Now ethylene diamine is a neutral ligand, so it has a charge of 0. And then plus, we have got 2 and 2, that is also 4. So we have got 4. And the charge of nitrogen dioxide, that is a negative 1. And then plus, we have got a sulfate. We know a sulfate is positive 2 charged. This should give us a 0. So this is giving us that ion. Okay, that is ion. And then we have got 4 times 1, that is a negative 4. And I've just forgotten up one thing here. This 2 which is here is applying to everything that is inside. So even the ion, it applies. So I was supposed to put a 2 in front there. So 2 times the oxidation number for ion just like we are multiplying with the rest. So this is a 2. Now we have got, and by the way, also the sulfate. How do we write a sulfate? A sulfate is SO4 2 minus. The charge is negative 2, not a positive 2. So that would be a negative 2 inside there. So I've got 4 times negative 1, that is a negative 4, and then minus 2, which is just a negative 6. And that is going to be equal to 0. Now we take 6 the other side, so that will be 2 ion is equal to positive 6, and dividing both sides by 2, that is going to give us a positive 3. So this is the charge of ion in this compound. Now let's get to name it. The first thing, remember, is to name the ligand. But now this ligand is called ethylene diamine. And how many are they? There are the 2 of them. So when we are naming these compounds, and it already contains a di, and there are the 2 of them, so we are supposed to say diethylene diamine. So we see that the dies are appearing 2 times. So for such a case, we have got special cases as those. When you are naming something that is repeating, you don't use di. In this case, we are going to use bis. Okay, that is what we are going to put. We use things like bis, tris, tetrax. In an example where we've got maybe 4 which are repeating, tetrax, and then we've got a bis, and then a tris. But because we have got the 2 of them, we are going to use bis. So this is going to be bis, and then we have got ethylene diamine. Now after naming that, we name this before we can name the ion. And what is this? This is nitrogen dioxide. But remember, we said when nitrogen dioxide is appearing as a complex ion, what do we say? So that is going to be di. We add an O when you have got a ligand. For ligands, we add an O at the end, just like bromo, chloro. Even this is going to become dinitro, because we have got 2 nitrogen dioxides. So that will be dinitro, and then we have got ion. The charge is 3. Ion 3. Now we name the sulfate. So that is going to be the name bis ethylene diamine dinitro ion 3 sulfate. Let's consider C, how we get to name it. Now if we can look at this compound, what has been named first is the metal, and then we have got the complex ion. So in this case, the complex ion is not the cation, it is the anion. Remember, when we are naming, you always start with the cation. So all I'm going to do is to find out what the charge of ion is in this compound. So I've got 3 potassiums, and the charge for potassium, we know that is positive 1, plus we've got ion, and then plus we've got 6 cyanide, and the charge for 1 cyanide is negative 1. This should be equal to 0. So this is a negative 6 plus a 3, that is going to be a negative 3. Taking it the other side, so the charge for ion is going to be positive 3. Therefore, to name this, it's going to be, first we name the potassium. Potassium, that's the name. And then we get now to name first the ligand before we can name the metal. So the ligand is what? Cyanide. And for the ligand cyanide, we use cyano, that we know. So now how many are they? There are the 6 of them. So that is going to be hexa, cyano. And then now, because ion is appearing in the anion, it's not appearing as a cation, you're not going to name it as ion. So that will become now ferrate. So that will be ferrate. The charge is positive 3. So put in Roman numerals. So that is going to be the name, potassium hexacyanoferrate 3. What of the other one which we have? Part D, Cr H2O 4, we have got Cl2 and then Cl. So here the complex ion has been named first, so I'm going to name the complex ion first. Now let's look at our metal ion which we have here. We have got chromate. What is the charge on the chromium? So we have got chromium plus, we have got 4 water molecules. The charge of water is a neutral ligand, so it's 0. And then plus we have got 3 chlorines. So, and we know that each chlorine is -1 charged. That will be equal to 0. That means a chromium, the charge here is +3. So therefore the name is going to be, how many water ligands do we have? We have got 4 of them. Therefore the name is going to start with, for 4 we name it as, that is tetra. Just like 2 is di, 3 is tri, tetra, penta, hexa, hepta, like that. So we have got tetra. Now when we have got water as a ligand, we don't name it as water, it is aqua. So that is tetra aqua. Now we name first the chlorine here. So tetra aqua chloro, and then we come to the chromium. So chromium, chlorochromium. The charge is a 3 using Roman numeral, and then we name the chloride, which is the anion in this case. So that's tetra aqua chlorochromium 3 chloride. That is the name. And the last one on here, how can we name it? Well, you can just try to pause the video and see if you are able to work it out, and you can confirm after then. So here we are using sodium as the cation, so we are going to name it first. Now the ligand here is chlorine, so we first need to understand what's the charge of our tin in this case. So we have got 2 sodium. We know the charge of each sodium is +1, and plus is tin plus 6 chlorine. The charge on 1 is -1. This is supposed to be equal to 0. So 2 plus 1, that is a +2. 6 times -1, that's a -2. So that is going to give us a +4. So tin in this case is giving us, it's a -4, but if I take the number over the other side, it becomes +4. So that is the charge on tin. Now let's get to name it. How does it go? So we first name the sodium, and the sodium in this case, we'll just name it direct as sodium. After naming the sodium, now we are going to go inside. Now as we get to name the inside, we start first with the ligand, and we have got the 6 of them, so that will be hexa. Now the ligand we have here is chlorine. How do we name it? So that will be, when we have got a ligand as chlorine, we name it as chloro. Okay, and then we have got tin there. Now how do we get to name tin? So tin, because it is, in this case it is on the anion, we name it with the name stannate, which is a Latin name. Just like copper, we could have named it cuprate. So this is going to be stannate. Now what's the charge of the tin? That is a 4. So we get to put the Roman numeral there. So the name is sodium hexachlorostannate 4. So that is the naming of complex ions. Now let's just get to see this as the last question. Give the formula of each of the following. We have got triamine bromoplatinum 3 chloride. I mean 2 chloride. How do we get to name it? We can see that we are naming first the triamine. That means we have got 3 ammonia. molecules. That is why the name comes as triamine. So we're going to write ammonia, the three of them. And here we've got triamine bromoplatinum. So because we have got bromo, that means we are supposed to have what? Bromine. And then platinum. Now the platinum, that is a metal, is going to be in front. Okay, we're going to put a platinum there. And then we have got a chloride at the end. So that is going to be the name. So this chloride is symbolizing the anion in this case. So this is the name. This is the formula of that name, triamine bromoplatinum 2 chloride. Now let's look at B. Potassium hexafluorocarbotate 3. So for this one we are starting with the potassium, so that is potassium. And then now we name the anion which contains the ligand, and that one we have got hexafluoro. That means we have got 6 fluoride atoms. So I'll put F6. And then we have got what? A carbotate. We name always the metal should be in front. So the charge is what? Positive 3. So this is the compound, potassium hexafluorocarbotate. So that is going to be the compound, this one. Now we also have C, which is sodium hexachloroplatinate, where we are also starting with sodium. So we're going to write a sodium first, like that. Now we have got sodium hexachloroplatinate. So hexachloro, that means we have got how many chlorines? We have got 6 of them, so that would be Cl6. And then platinum, platinate, so I'm supposed to have a platinum here. Now we need to put the right number of sodium atoms, because not only one sodium. We see that this thing has got okay, the platinum supposed to have a what? A positive 2 charge. So let's see. So sodium plus, we have got 2 platinate, that's not a positive 2 charge. So this, how do we tell if it's positive or negative? So let's just look at the chlorine. We have got 6 chlorines. Okay, we know that the chlorine is what? Negatively charged, -1. And then that means the platinum is the one now which has got a what? A positive 2. Okay, like that. Because these are have got counter ions. If this one is positive, if the anion, I mean not the anion, but this ligand is negative, this is going to be what? Positively charged. That is how these compounds are formed. Anyway, say metal, we will know that metals are always positively charged. So this will give this, the charge is supposed to add up to 0. So we are saying that sodium 6 minus 1, 6 times -1, that is a -6, plus 2, that is a -4. So taking the other side, it becomes +4. So we are saying that the oxidation number of sodium is supposed to be a +4. So the only way it can be a +4 is when we have got 4 sodium atoms, because the charge of 1 sodium is what? +1. So that is how it's supposed to be. For all of this, if you do the same, that is how we went with them also. It's just that one atom was just working for those, so I didn't show the whole procedure. Now let's look at the last one, potassium hexacyanoferrate. So we have started with a potassium, and then hexacyano. So we have got cyanide, and how many are they? There are the 6 of them. And then we have got ion 3. Okay, like that. Now let's see how many potassium atoms we need to have for this to be a proper formula. So potassium plus ion, they've told us the charge. Just from looking at the name, supposed to be +3 charged. And then plus we've got 6. We know a cyanide is -1 charged. This is supposed to add up to 0. So potassium is going to give us 6 times negative 1, that is a negative 6. 3 plus negative 6, that is a negative 3. Taking the other side gives us a positive 3. So the charge of potassium should be positive 3. That means we need to have 3 of them, because the charge of 1 potassium is what? Is only a positive 1. So these are the formulas. This is how we can be able to write the formulas and also determine the names. Well, thank you so much for watching. If that was helpful, please be sure to subscribe and continue enjoying. Stay blessed.